Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds product of nodes at kth level in a tree represented by a string. First, let us take an example. We take input an integer k and a binary tree in string format. Every node of a tree has value in range from 0 to 9. We need to find the product of elements at kth level from root. The root is at level 0. Now let us have a look at the algorithm. We take a sample string tree. Also, let us assume that k is equal to 2. Now, in the product at kth level, we initialize a level variable to -1. Next, we take a product variable and initialize product to 1. Now, integer n will store the length of the tree string, which is 19. For better understanding, let us also take a graphical representation of string tree. Now, we enter the for loop and initially I will be 0. We check if character at ith position in tree array is a closing parenthesis. As it is true, we increment level. Now, next iteration of for loop will take place. Now, element at index 1 is not an opening parenthesis or a closing parenthesis, and level is also not equal to k. So, we go to next iteration. The character at index 2 is a closing parenthesis, so we increment level. We continue with the for loop and increment I. Again, as element at position 3, which is 5, not a closing or opening parenthesis. Also, level is not equal to k, so we go to the next iteration. Element at position 4 is a opening parenthesis and hence we increment level. Next, we increment I. Element at position 5 is 4 and since level is equal to k, we make product equal to product into 4. Then we increment I. Element at index 6 is an opening parenthesis and hence we increment level. Then we increment I. Now element at position 7 is a closing parenthesis and hence we decrement level. We go to the next iteration. Element at index 8 is an opening parenthesis, so we increment level. We move on to the next iteration. Element at index 9 is a closing parenthesis, hence we decrement level. Now I will be 10. Character at index 10 is a closing parenthesis, so we decrement level. Now I will be incremented. Element at index 11 is again a closing parenthesis, hence we decrement level. We move on to the next iteration. Character at index 12 is an opening parenthesis and hence we increment level. I will now be 13. Element at position 13 is 7 but level is not equal to k. So we increment I and go to the next iteration. We have an opening parenthesis at index 14, hence we increment level. I will be 15. Now at 15th index element is 1 and level is also equal to k. So we multiply 1 to product. I will be 16. At the 16th index we have a closing parenthesis, so level is decremented. I will be 17. Again, level will be decremented. I becomes 18. Level will be -1. Now, we reach the end of the for loop and return product. So, product at level 2 is 4. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.